Okay, everybody, good afternoon. So here our today's topic is what is factor theorem. Although this is not a new term for you all, but this is important for us to go through what is called the factor theorem. So before going to talk about factor theorem, you can see what is called the polynomials. Polynomials means any kind of function in terms of variable and constant. That is called the polynomial function. So like if a function has only one term, you can say this is monomial. If it has two terms, you can say this is binomial. Three terms, maybe trinomial, and in general we call that is polynomial. So this sort of function you can see here, this is called the polynomials, where this a1, a2, a3 are the constant numbers like 2, 119, 1, -5, and the numbers like that. That can be any number. But regarding this power should always be 0 or greater in that case. That means n minus r difference must be 0. That means n minus r difference, that means the power of this polynomial starts from 0 and goes on increasing like 0, 1, 2, 3, 4. But those n minus r must not be negative number. If that is negative number, we cannot say that this is the polynomial. Okay. There are some examples of polynomial. You can see here x and its degree is power is 1. So this is the polynomial of degree 1. Here you can see this is the polynomial of degree 2. But at this time you can see the index of x is 3 and here x times y. If you add them, so in this case the power is going to be 2 here. Total power of the variable is going to be 2 here. That means this polynomial has degree 3. For example, if I am putting here value of x as 2 and y as, for example, 3, then if you see the total power of the variables is 2 and 3, so 2 plus 3, 5. So in that case, the degree of this polynomial is going to be 5. Now here you can clearly see the highest power is 2 and here the highest power is 3. So this is the polynomial of degree 2 and this is the polynomial of degree 3. So now we are going to talk about what is the factor theorem. So in order to explain that, let me clear it off. So I am taking some example. For example, here say it is px is equals to x cube plus 2x squared minus 11x plus 6, and this sort of thing is going to be divided by x minus 2. Now we shall check whether or not x minus 2 is factor of this polynomial. If x minus 2 divides this polynomial completely, leaving no remainder, in that case we can say x minus 2 is the factor of this function or this polynomial. Alright, so let's check it here. So it is going to be x cube plus 2x squared minus 11x plus 6, and we are now going to divide this by x minus 2. So how do we divide it? So all of you know that how to divide that. This is x cube, so we apply here x squared, so that is going to be x squared times x is x cube, and then this is minus sign here, so minus 2x squared, and this is minus, this is plus, these two are going to be cancelled, and here 2 plus 2 is going to be 4x squared, then remaining terms are minus 11x plus 6. Now another time it is 4x squared, so we apply here 4x, we apply here 4x, then 4x times x is going to be here 4x squared, then another term is minus 2, so it is going to be 4 to the 8x, and then lastly it is minus and this is plus, and these two terms are cancelled out, so negative sign is bigger here, so minus 11 plus 8 is going to be negative 3x plus 6. Now another number that you divide by is 3, minus 3. Okay, so not the plus, actually this is minus 3. So minus 3 times x is minus 3x, and minus times minus, that is negative times negative, make plus, So it is 3 to the 6, and finally you can see this is plus and this is minus. Both the terms are cancelled, and here you are left with the remainder 0. So as the remainder is 0 in this case, therefore x minus 2 is called the factor of this polynomial. Okay. Now how you can express this? For example, let me take the example of a number, for example. So here one number I am saying that 18 is going to be divided by 6, and then the answer is 3 times of, the answer is 3. And also you can say 8 is going to be 3 times of 6. What does it mean? That means as 18 completely divide, as 6 completely divide 18, and it has no remainder, and the answer is 3. Therefore 3 is a factor of 18 because there is no remainder. So if you compare that with the given polynomial thing, so this is the main function px, and that is going to be equals to 3 means this is the divisor. You can see the divisor is x minus 2, and that will be the function. So it is 3 times of 6. 6 is the divisor. Yes, x minus, in place of x minus 2 there is 6, so 6 is the divisor and 3 is the quotient in this case. So for example 18, 6 and 6 3 ja 18, remainder is 0. That means this is quotient, this is divisor, and this is the dividend. So you can write this quotient as, if you express in terms of function, then this is going to be equal to divisor times the quotient. Quotient is always the answer. Then how do we express this function now? Because when it is divided by x minus 2, then your answer is x squared plus 4x minus 3. So note it down somewhere. It is going to be x minus 2 as divisor, and x squared plus 4x minus 3 is going to be quotient. So I am clearing off some space here. So when you divide this polynomial given by x minus 2, then what do you get? If you compare here like this, then your px is going to be x minus 2 times x squared plus 4x minus 3, leaving no remainder. So if there is remainder 0, that means x minus 2 is the factor. So what you can say actually, so therefore for if you put x minus 2 equal to 0, that gives you x equals to 2. So therefore at x equals to 2, you can say P2 equals to 2 minus 2, and this is x squared plus 4x minus 3, and 2 and 2 cancel out, so it is 0 times of the same number, same polynomial, x squared plus 4x minus 3, and it makes it 0 again. So this is called factor theorem. So what did you notice here in this case? In order to say the factor theorem, x minus 2 must divide the given polynomial px exactly, and in that case x minus 2 is the factor, and when you put the value of x in this case as x equals to 2, that will make the whole polynomial 0. We say that the remainder is 0, that is there is no remainder. It means this sort of term is called factor theorem. And let's generalize it again. So if you generalize that, for example, say px equal to, just like before, it is a1xn plus a2x n minus 1 plus a3x n minus 2, and suppose that your divisor is x minus a. Okay. Then, and the quotient in this case is, for example, any number b1 x n minus 1 plus b2 x n minus 1 b2 x n minus 2, and like this. Then you can express Px equals to x minus a times Qx. So when x is equals to a, then P at x equals to a is going to be a minus a times Qa, and a cancels, so 0 times Qa is going to be 0, and therefore this is known as factor theorem. Every time note that if the remainder is 0, the given number is going to divide the given polynomial completely and leaving no remainder. In that case, here in this case, it is x minus a is the factor of the given polynomial, and therefore this sort of thing is called factor theorem. Okay, I will now do one example based on this factor theorem. So let me clear it off first. Now I am taking one reference example from the book. So this example states that, you can see here, like, given that completely. Okay, now you can make the note of this question. Once again, I am going to read it out. Your question is, given that 3x squared plus 5x minus 2 is a factor of 3x cubed plus 17x squared plus ax plus b. What does it mean? This function is going to divide this completely as 3x squared plus 5x minus 2 is a factor of 3x cubed plus 17x squared plus ax. In that case, you have to find the value of a and b, and once you get the value of a and b, in that case, then you have to factorize this polynomial completely. So let's see how it can be done. So at this time, I'm doing question number A first of all. Now let's see some sort of thing here. So first of all, this is a kind of this is a polynomial in quadratic form, and if you divide the given polynomial by this quadratic polynomial, because number A and B are not open, we have to go to find it out. Then we shall do some statistical work in order to get to the point where we can get value of A and B, and we'll apply the factor theorem that we have done just now. So here, first of all, I'm going to factorize it. So factorize the polynomial that is going to divide another polynomial completely. So here, if I factorize this, x squared plus 5x minus 2, x squared plus 5x minus 2. So let's factorize it. What happens? This is 3x squared, and then this is 6 minus 1 x, and then this is minus 2. Open it up. I think all of you are used to all this sort of method. So this is 6x minus x minus 2, and then it is 3x squared, then 3x is common, so it is going to be x plus 2, and here it is minus 1 is common, so it is going to be x plus 2, and finally we have x plus 2 common, and then 3x minus 1 common. Okay, so we factorize the polynomial that is going to divide the given polynomial exactly, leaving no remainder. Alright, now do you think that one thing, as it is given that 3x squared plus 5x minus 2 is factor of this polynomial. Now what about its factor? Is x plus 2 is also the factor of the given polynomial? Is 3x minus 1 is also the factor of the given polynomial? For example, let's see, I'm taking again the numbers 18, and this is 6. So 6 3s are 18. We can say that 3 is the factor of 18. Now let's factorize the number which are divided 18 exactly, leaving no remainder. So 6, the factor of 6 are 1, 2 and 3. So 6 has divided 18. Do you think that is factor of 6 also is going to divide 18? Let's see here. 18 divided by 2 gives you value 6. 18 divided by 3 gives you value. What is this value? 2 is 9, sorry. This is 9 and this is going to be 6. So as 6 divides 18 exactly, then factor of 6 also divides 18 exactly. And you can see the situation over here. So therefore you can say that, therefore x plus 2 and 3x minus 1 are also the factors of the given polynomial, as these are the factor of the polynomial 3x squared plus 5x minus 2, which according to the question divides the given polynomial. So they are going to divide this polynomial. Alright. So now we note that 3x squared plus 5x minus 2 has one factor as x plus 2 and another factor as 3x minus 1. Now since x plus 2 and 3x minus 1 both are the factor of this polynomial, so that if you say it is px equals to 3x cube plus 17x squared plus ax plus b, then you can write p as it is x plus 2. I'm talking of one of the factor, and if you put x equal to x plus 2 is 0, that is going to be minus 2. That means this sort of factor, this sort of polynomial at x equal to minus 2 is going to be 0. So we put minus 2 and this is 3 minus 2 squared plus 17 minus 2, this is cube, this is whole, this is square, plus a times minus 2 plus b. So this is going to be 0. Why? Because x plus 2 is the factor of this polynomial, and therefore at x equal to minus 1, the remainder for this polynomial is going to be 0. So this polynomial is 0 at x equal to minus 2. So let's calculate it. This is minus 24. Then this is the square of negative sign, that means gives you plus 68, and this is minus 2a plus b. Therefore, if you take this to the left side, it's going to be minus 2. Minus 2 will be plus, and minus b will be plus b will be minus, so it is going to be minus b. And 8 minus 4 is 4. 6 minus 2 is 4. So one of the equation is this. So we have obtained one equation based on the value of x equal to minus 2. So therefore, for x equals to 3x minus 1 equals to 0, that is x equals to going to be 1 by 3. Your p 1 by 3 is again going to be 0, and that gives you the equation. In that case, p 1 by 3 means you put this value 1 by 3, so this is 3 times of 1 by 3 cube plus 17 1 by 3 squared, 17 1 by 3 squared plus a 1 by 3 plus b equals to 0. Your another equation will be like this. You can see your another equation as a plus 3b, a plus 3b equals to minus 6. So when you calculate that, you will have the another equation. So you can say this equation as 2. So let's rewrite these two equations. So when we solve these two equations, we will get the value of a and b. Then we have one equation as 2a minus b equals to 44. It was equation 1. And another equation is a plus 3b equals to minus 6. and that is equation 2. You can say that is equation 2. Now this is trying to solve these two equations in order to get the values of a and b. So instead of going through the detailed calculation of all these value, that is only the waste of time, I think, as you are allowed to use the calculator. So first of all, I'll go to mode, then 5. I can see that sort of thing is in function number 1, and then in function number 1 I put all these values. So this is plus 2, so 2 enter, then it is coefficient is -1, so -1 enter, and here it is 44, then this is 44 enter. Now I am to the another equation, coefficient is 1, so 1 equal, and then this is plus 3, so 3 equal, and then this is -6, so -6 equal. Now if I put equal again, then I have value of a. I have value of a equals to 18, and value of b equals to again equal, then value of b is equals to -8. So I know that you can't see this value on the screen here because it's not that clear, but you know the method how to use calculator in order to solve the linear equation. So you can use that function in the calculator. Okay. Therefore, our px will become, it is 3x cubed plus 17x squared plus a value is 18. A value is 18x, yes, 18x, and then -8. Now I will go to the part B. So I'm going to clear off everything from here, and then I will proceed to question B. The question B says that factorize the polynomial 3x cubed. So you have two methods to do this. One method is that you divide this polynomial by the given polynomial to be divided, that divides this polynomial exactly, leaving no remainder. So that was 3x squared plus 5x -2, and then we leave some space over here. So this is 3x squared and this is x cubed. So you start with x, so it is going to be x times x squared x cubed. So this is 3x cubed, and then this is plus 5 times x times 5x is 5x squared, and then it is subtract these two terms is cancelled now, so it is 11x squared, and then the remaining terms are plus 18x -8. Now no, we have another term also -2, so -2 times x is going to be -2x here, so it is plus now, so it is 20x -8. Now we try with 4 now, so 4 3 ja 11, no, this is 12. Okay, so 4 3 ja 12x squared, and 4 5 ja 20x minus 4 2 ja 8, minus plus, so these terms are cancelled and leaving no remainders. So therefore 3x cubed plus 17x squared plus 18x -8 is going to be, your previous factors were 3x -1, and then it is x plus 2, then x plus 4 that we have got just now here. So in this way you can factorize the polynomial completely. Okay, now would you also be interested in factorizing the thing by another way? Another way means by comparing to the both sides, and then we can see that how it can be done. So what you can do in this case, like, let me make some space up here. Okay, so here you can see it is 3x cubed plus 17x squared plus 18x minus 8 and 3x squared plus 5x minus 2 multiplied with cx plus d, for example. Now we can just compare to the both sides. So cx plus d means one of the factor will be in terms of that c has some constant value and d also has some constant values. All right. So let's see the power of compare the power of x cube here. So when cx multiplied with this, then there is going to be x cube term. So comparing both sides, what you can get here, 3x cube is equals to 3cx cube. Actually, you don't need to write this. So just you write the constant term while comparing to the both sides. So that gives you value 3 equals to 3c. Therefore, c is equals to 1. Now, what about the value of d? D you can see with the you can compare with the constant term. I think there will be only one constant term. So for example, if you multiply minus 2 and d to the right side, it's going to be minus 2d. Equals to the left, you can see there is only one constant term here. So that is going to be minus 8. Therefore, in this case, d value is going to be 4 in this case. So therefore, one of the factor is c is 1, so 1x is 1 and plus 4. And rest other factors where it was 3x minus 1 and another was it was x plus 2. So this is also the way that you can calculate, that you can factorize the factor by comparing left hand side and right hand side. So once again, I would like to tell you that to learn through different ways still, okay, especially when you are in the practice mode. But for the exam, for other purpose, you can adopt any method that you feel is easy to you. But in general, while learning, try to see the same problem in different ways. Again, we shall now see what is remainder theorem. So let us consider a function like this. It is 6x cubed minus x squared minus 18x, and that function is going to be divided by 2x minus 1. So this is the general way of how we divide it. You can have a look at here that how we divide, and in that case you can see the quotient is here. This is the area of quotient, so place of quotient. So this is 3x squared plus x minus 17 by 2. That is the quotient. In this case, 2x minus 1 is the divisor, and minus 15 by 2. After the division, we have got the remainder as minus 15 by 2. And this is the given function that is to be divided by 2x minus 1. So once you divide with 2x minus 1, the remainder is, there is some remainder like minus 15 by 2. That means we can say that 2x minus 1 is not the factor of the given polynomial. In order to be 2x minus 1 as factor of the polynomial, there must be remainder 0. But at this time, as we are talking about remainder theorem, then we shall look for some pattern that we can develop through this kind of division. So in order to let you understand that how division of the things can be expressed, I am taking here a simple example of dividing 9 by 2. So here you can see when 9 is divided by 2, this is the process, and after that this is 4 whole plus 1 by 2 we have got from this division. So 9 by 2 can be expressed in this way also, 4 plus half. After taking the LCM and simplifying this, it is 2 times of 4 plus 1. But at this time I am not multiplying 2 and 4 because I have to develop some pattern to give it to the remainder theorem. So in that case, now in this case you can see 2 and 2 cancel out. So 9 can be expressed in terms of 2 times 4 plus 1 when it is divided by 2. And the same sort of thing you can see in the algebraic form also here, like 3x cubed minus x squared minus 18x plus 1 is divided by 2x minus 1, and then if you have look at here, this is the whole number, the whole thing, that is the position of quotient. So just like saying 4 whole 1 by 2, you can say this whole, this minus 15 by 2, and then divided by 2x minus 1. So from this step to this step, it has been expressed just like in here. Now I am taking the LCM. LCM if I take, then it will go to multiply over here, and then at this part we are left with negative 15 by 2. Now comparing both sides, these two terms have been cancelled now. So our fx 6x cube minus x squared minus 18x plus 1 can now be expressed as this denominator, that is 2x minus 1, 3x squared plus x minus 17 by 2 and plus minus 15 by 2. Now let's see what are these. So here in the division area, this is the dividend, and this is the quotient. We express that as qx, and this is the divider. So you can generalize the function like this. 2, you can say this is value a, x is there, and minus 1 you can see value b in general. Why I am writing a and b? Because this can be, these constants can be anything like 2, 3, 4, 5, 9, 6, 11,